Student Handout 5, Analyzing Functions and Graphs. A graph function may display different properties and characteristics over certain intervals of the graph. In A and B below, describe the parts of the function over the specified intervals as linear or straight, nonlinear or curved. Increasing would be a positive slope and decreasing would be a negative slope. All right, so in A, between 0 and 3, we have an increasing yet nonlinear line. So we would say increasing and nonlinear. While between 3 and 6, we would say that it is decreasing because it's going down. We have a negative slope and nonlinear. Still that little curve to the line. All right, but in B, where before we would normally look at that and say this is nonlinear, now if we look from -3 to 0, we see that we have a linear yet decreasing line. So we would say that this is linear and decreasing. And then from 0 to +3, we have an increasing and linear line. So here we would say linear still and increasing. Okay, we can apply the characteristics of functions over different intervals to interpret distance versus time graphs, which show how far an object has traveled over a given amount of time. We did this with our graphing stories. I don't know if you remember that, but the graphs in A through E above compare an object's distance over time. Use the characteristics of the graph to write a description of what the graph represents. So in A, we are increasing our distance over time, and since it's linear, our slope means we're moving at constant speed. So the object is moving away at a constant rate. Which is speed. Okay, the speed is the same. While in B, we are getting closer, our distance is decreasing over time. So we would say the object is moving closer at a constant rate. Or again, speed. All right, in C, our distance isn't changing over time, which would tell us that the object is at rest. So it's at rest or not moving over an interval of time. So it's not getting closer or farther away. And then in D, we can see that the distance is quickly getting further away and then a little slower. So we would say that the object is moving away because the distance is getting further at a decreasing speed. Decreasing rate or speed. Okay, and in E, it is slowly getting further away, and then all of a sudden it goes away really fast. So we would say it is moving away at an increasing rate, or it's speeding up. get our parenthesis in there. All right, let's flip over to the back side. So Tyson is driving, and the graph below represents Tyson's distance from his house. Write a brief description describing Tyson's drive. So over time, he's getting further away. And then remember, a straight line meant stationary, so he's staying where he's at for a certain amount of time, and then he's driving home again. So I would say that he is driving away. So Tyson drove away from his house, stayed there, or stayed in one place, probably his friend's house, for a time, and then drove home. Okay, so number 2, Maddie is walking to volleyball practice, and the graph represents Maddie's distance from the gym. Write a brief description of Maddie's walk. So I would say that she is walking at a constant speed, and then she stops somewhere for a little bit, and then realizes that she stopped too long, so she hurries faster, getting closer, and she gets tired and slows down as she goes. Okay, so Maddie walks at a constant speed, stops to talk, and realizes she's late, so then walks really fast and finally slows as she gets closer. And you could say she stopped to do anything. Maybe she stopped to get a coffee or some food at McDonald's. But she did stop and stayed in the same place for a little bit. Okay, 3, the graphs below represent the distance of 3 students from their houses. Write the letter of each description over the graph it matches. All right, so A says, Kaylee got on the bus at her house. The bus made 2 more stops before it arrived at the school. So she's continually getting further away from her house. So I would say that's this one, because she moves away from her house, then stops to pick up some kids, moves away from her house, stops to pick up some kids, and then moves away till she is at the school. Okay, so we are going to say this one is A. All right, B, Brennan and his dad left for school. They got stopped at the train tracks before they were able to continue to school. So that is the first one. So they stop at the tracks for a while, and then they go and they get to school. So this would be B. And the last one, C, Cameron left for school, but had to go back home to get his English homework. He then drove to school with only 1 stop at a stoplight. So he drives away, realizes he forgot something, goes back home, he's there for a minute grabbing it. Then he drives away, gets stopped at the stoplight, and then is able to continue on to school. So this distance right here at 0 would be home. So he goes and comes back. All right, so this is C. Okay, number 4. Sketch a distance versus time graph showing Adam's distance from his house. Label each segment. So A, he left his friend Brody's house and started walking home. So he is away from his home. So he's up here, and he starts walking home. Adam realizes he left his phone at Brody's, so he goes back. So over time, he's going back the same distance, and we can say he walked about the same pace. So now he's back at Brody's house. So this would be A. This is B. And then Adam left Brody's a second time. So he's probably at Brody's for a little bit picking up his phone, right? Okay, so then he leaves a second time and starts walking home again. going a little faster because he knows he's late. And he stops halfway to talk to a friend he passed. So he talks to his friend for a little bit of time. So this is C. The stop would be D. And then he quickly ran home to make it home for dinner. So he zooms home. So it's kind of, we're going to say slows down a little bit, but he gets even steeper. And then he slows down as he gets closer to home. So this would be E. All right, let's do the last problem here. Ruby and Gia race each other in a 150-meter sprint. The graph shows the distance of each runner over time. Who won the race and how do you know? All right, so this is time. So looks like it both ended. They both made it to the end of the 150 sprint. But the time that Gia ended was about 23 seconds, while the time that Ruby ended was 30 seconds. So Gia won. She finished in 23 seconds. Okay, was the same runner the lead the entire race? Well, how high the line is distance, so it looks like Ruby had gone a further distance than Gia, all the way up until about 21 seconds. So we would say Ruby was in the lead until 20 seconds. So it was the last 3 seconds of the race, Gia won. How did Ruby's pace differ from Gia's? So Ruby has this straight line, just straight all the way through. So Ruby ran at a constant rate. But if we look at Gia's, she is slowly getting faster. So Gia's speed slowly increased over time.